squirrel map.
Funny beeping noises. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 267. We'll be talking metal casting, plasma cutting, and a spicy 555. This week in Hackaday news, we had two conferences on two different continents. Over here in Europe, up in Berlin, we had Hackaday Europe last weekend, and it was fantastic. So that was really good to see you all.
I heard the lightning talks were great. Yeah, I was jealous I didn't get to make it.
Lightning talks are always so fun because it's like, lightning talks are like a box of chocolates. You don't know what you're going to get, and each one is short and sweet and to the point, and it was loads of fun. And they were just a huge spectrum. Oh, and then the other conference going on this weekend was VCF East, Vintage Computer Festival. Tom was there. He wrote it up for us already. I guess I'll have a Hackaday Europe write-up coming out as soon as I get the photos all processed.
I was going to say, are you driving over to the photo mat to have them developed? Is that, was I given to understand that?
And with the resolution of digital cameras these days, it takes so long to get them developed. I mean, you can't even imagine all those bits. Let's see, yeah, VCF. And Tom's conclusion was that it was bigger and better than ever. I don't know what it is. Is vintage computing so hot right now? Is it some kind of retro nostalgia? But then, of course, Tom says there is kind of cross-generational attendance to these things too. So it can't just all be graybeards who love their retro computers. I don't know. Anyway, really neat. And he has his highlights, but his general feelings as well written up in this article.
I noticed that in the Dallas one too. There were a lot more younger folks. Of course, I mean, everybody's younger compared to me, but seriously younger folks at the VCF that I attended in Dallas than I would have expected. So I saw an article today, I think, or yesterday, that typewriters are making a resurgence. So maybe there's this neo-nostalgia, right? You play your records on vinyl, you take film cameras are having a little resurgence, typewriters, maybe it's vintage computers are in that mix.
Fair enough. Whatever it is, I do think you can learn a lot from kind of simpler computers. And I think a number of us have had that experience. I think that was Tom's slant on the VCF, actually. The first time he went there it was the first time he'd come into contact with, a computer that just has a bunch of switches on the front panel and you enter the opcodes that way. And that was, a revelation for him. I'll admit I had a little bit of that experience with Voya's SuperCon badge from 2 years ago, which was a custom 4-bit computer. So, I do think there's something, over and above the retro cool factor. But you also do have to admit that there is kind of a retro cool thing going on in the air.
There's something very attractive about having a computer that a mere mortal could actually understand all of it from soup to nuts, and right. Modern PC, sorry, I mean, if you have no life, you could probably understand all of it. It's not that it's magic, but it is a lot. Any of these older computers, it's not a trivial thing to understand all about them, but it is doable. I'm going to put a link in the show notes. We did a article about how to use switches to enter things, I think for the PDP-8, and it was with a simulator, so you could see it, and there's a video, and I'll dig that up and put it in the show notes. But if anybody has not had that experience and wants to relive those glory days, which we don't miss, I'll put that in, and you can suffer the way we all suffered. So
it's not something you want to do every day. Like, it's not something you want to have to do, but it's something you should do once or twice, right? What do you think?
I think so. I think it's, the biggest thing that always taught me programming was typing in listings from magazines, which of course no one would do now. You couldn't make people do that with a gun.
Yeah.
But you'd say, oh, that program looks cool. I'd like to play with it. Well, let me start typing for 3 days. And then of course it wouldn't work because you can't type all that correctly. So then you had to learn how to debug what was wrong with it, which was your fault. I mean, it wasn't like the program probably had a problem. Although sometimes that was true too. So typing stuff out of books and magazines is very instructive.
This is a journey into sound.
What's that sound?
What's that sound?
All right, should we head on off to What's That Sound?
Oh boy.
This week's What's That Sound is a special exception What's That Sound. Al came up with a really great idea for the sound, But then he told me what it is. So I can't test it on him. He can't test it on me. We have to try it out on you. So, dear listener, have a listen to this sound and see if you can guess what it is. Yeah, so it takes all the fun out of it that we don't get to embarrass ourselves in front of a large studio audience. But if you know what the sound is, head on over to hackaday.com/podcast. Fill in your best guess and your handle, and we'll draw from among the correct answers next week and see who gets a Hackaday podcast t-shirt.
Good luck.
My first hack this week comes from Denny, whose YouTube channel, Shake the Future, has shown me more about microwave oven metal casting than I think any other resource. And this goes way back. The current article covers 2 videos of his that are making the rounds right now, which detail his complete setup for doing metal casting in a microwave oven, kind of on a home hacker setup. It's really fantastic. He's been refining this technique for at least 5 years now, and I know we wrote about him back in 2019. I'll show you that one so you can compare and contrast. But basically, his system involves making a do-it-yourself crucible out of silicon carbide, and silicon carbide absorbs the microwave, so it gets brutally hot. You then contain this thing in an insulated package made up of ceramic fiber blanket wrapped in Kapton tape. He spends a lot of time making this thing close up nice and tight and covers the edges of the ceramic blanket with like an aluminum oxide nonstick slurry so they don't get damaged with repeated use, etc., etc., etc. But given that it takes like about an hour to build his whole setup at all, like, I don't know, it seems like a little bit of overkill to me. I think if you wanted to do this yourself on the quick and dirty, you could probably get it done in a weekend. But his videos go through all of the details here, and that's really one of the strengths of his videos is how well he covers all of like the minute details. And when he's mixing it up, he'll say, I did it this way, and then it didn't work because it was too brittle. And so then I changed the mix to have more water glass in it. This is the mix for the silicon carbide crucible. And then that was fine. But then it worked better if you dried it out and then pre-baked it. And, so he's got all of these kind of failures to look back on and tell you about how to avoid them. And I think that's really great too. Basically, he's doing all this so that he can make small metal pours into plaster of Paris mixed with sand that he has put a 3D printed mold into. So he's doing lost PLA casting of metal, mostly aluminum, but he's also done some higher temperature metals too, all in a microwave oven. Really cool. I didn't know that this was possible, frankly.
I almost picked this one this week myself, and I didn't. But main reason I didn't is it scares me to do this in a microwave in my kitchen.
Don't do it in your kitchen. Do not do it in your kitchen.
Yeah, I don't think that's a good idea either. And I know you and I both have some traditional lost wax casting experience in our backgrounds, but there's a couple of things I think I should not do because I make too many errors. And so hot metal, hot glass. I think if I were in space, I need to be in space like the Enterprise, not like spacewalking outside the ISS, because I'm going to make a mistake at some point, and the mistake is not amenable. So this struck me as that sort of thing. If you're really careful and you can, especially if you have a microwave out in your shop somewhere where it's maybe not such a health hazard. But all the vacuuming to get the bubbles out of it and all that, I was thinking, yeah, I know I'm going to suck brass into that pump and cause a fire or, there's going to be something, right? There's no way I'm going to execute all those steps and not, at the very least, the best result is I burn my house down. So, but it was very cool. I agree. I'd love to actually try that if I had a fire extinguisher and a big insurance policy. So.
I don't think you want to be reusing this microwave oven for food anyway. So this is definitely something you should be doing in a shop or a basement or, a place with a fireproof floor. He's doing the pour of molten aluminum on a wooden tabletop. And I'm like, wouldn't it be cool if that were a fireproof tabletop? Maybe it would. I don't know how hot the aluminum gets. Maybe it's not such a big problem, but whew, boy. So he makes the crucibles by taking a bunch of silicon carbide powder and water glass and, making a slurry of it, packing it together, and then letting it dry. And in principle, that should be fairly strong, but if it cracks, you've got a leaking cup of molten aluminum if you're lucky and it's only aluminum, right? You've got a cracked cup of molten metal, and that's just a bad thing to have going on. So until you're pretty sure about your crucible making techniques, at least, I would treat this with utmost respect. I think that part is, of course, for sure. Yeah, you mentioned the vacuum table. He pulls the metal into the mold by making a really cool vacuum table attachment. And this is like completely hacked together, low tech. He's got a silicone tube that's fairly long to the vacuum cleaner. And I think that's going to save you from burning your vacuum cleaner up, Al. I don't think you have to worry about that part of it. But then it goes into like a filter thing from an espresso maker. And then over that, he's got a swim cap. So it's like a little shower head funnel with a swim cap on it. And the swim cap serves as a silicone gasket that then surrounds his little plaster molds that he pours into. And so what you get there is that if you don't do this vacuum technique, you kind of run the risk that maybe the aluminum doesn't stay hot enough long enough as you're pouring it in. And so it forms a block when it's like halfway through your mold. And here it's kind of like slurping the molten aluminum through the mold. And that helps a lot with making sure that it's a 100% cast. So man, really crazy. And I'm just surprised by how quickly he can melt the metal. Like he's putting between kind of 50 and 100 grams of aluminum into the microwave, and he gets it to melt in 5 to 10 minutes. So it's like the only time I've ever cast aluminum, it took like 45 minutes even just to get the thing up to temperature to even start melting the aluminum, much less, the melt itself when we were tossing cans into the pot. So this is really, really an impressive setup he's got there. It's, it's small, it's precision, but it seems to be super, super refined and fairly accessible, I would say.
It definitely looks like fun. And, I take it that was for practice because it was a little overdone for the actual problem, right? But presumably you get your technique done and then you could do something great. But, it was, what was it, a towel? Was it a towel hook or no, it was some.
Yeah. Yeah. It was like a coat rack hook or something.
Yeah. And it's like, you maybe could have done that a little easier than casting a new one out of metal, but great job,
If you are able to do something like this and you do end up needing kind of small metal pieces and you can 3D print the positives for the mold, then it makes it all that much easier to do.
Sure, the world's your oyster then. So my first pick for the week was Mano Aristita, Delays and Timers in LT Spice with no 555. It's a running joke among us that anytime we publish something that's got any sort of remote time relationship, the comments will be, well, that could have been done with a 555. And this is not about 555s, but it is a lot about what makes a 555 work. 555 is really just a collection of parts, essentially. So you charge a capacitor with a current source, you compare it to some voltage, and you turn it off or on based on that voltage in different ways. So it's a lot of little pieces. And what Mono did was basically show us how that works in LT Spice. And that's something I'm always really interested in, is I feel like we're in this kind of odd space now where, the amount of times you have to go grab a bag full of resistors and capacitors and build something is not as common as it used to be. Because first of all, you can get a 555 chip and it's just this black box and you go look up how to wire it up to do what you want to do and you're done. And then of course, nowadays, you just as likely take a microcontroller and say, okay, I want a delay for so many seconds. And he really looks at delays and timers, and usually, of course not always, because there's always an exception to something, you're basically depending on the charging of a capacitor. And if you just put a voltage on a capacitor, it charges up with the exponential curve. And the math behind that's pretty entertaining if you ever dig into it. but it's not very convenient, right? It's not a nice linear response. So of course the trick to that is, and again, the math's hairy, but if you charge a capacitor with a constant current source, you get a nice linear time charge. So, if it's charged up to 10% in 1 second, then you can calculate how far it's going to be for the rest. So I really liked the use of LT Spice to kind of build intuition for that. I've written a lot about that myself. We've got the VR circuit series and things like that. And I think it's one of those things that if you really want to understand what's going on, instead of just saying, well, I grabbed a 555 and I used it, this is the kind of thing you need to know. And I thought he did a great job presenting it.
I'm throwing in a link to our 555 timer contest of 2022. And there are a whole bunch of people kind of use the various parts that are inside the 555 as their own thing, right? Like, you said it's got a comparator and it lets this voltage ramp slowly up and then it trips when that hits, right? And then it has a flip-flop. And so we had people who used, like just the flip-flop to make a computer, or, just the comparator part in the 555. So, it is possible to not just blink an LED on and off with it, but do more, because in the end, these are the basic building blocks of computers. Back about 10 years ago, there were people who were looking seriously into how you could make the 555 into a good sounding audio oscillator for synthesizers. And that means making sure that the pitch changes accurately with the voltage. So putting a good voltage to pitch converter kind of thing at the front, and making sure that these kind of actually slow switching times in the comparator don't make your sounds go flat as they go higher in pitch and stuff. And so, it's a good part for what it does. And so this deeper kind of analog simulation like's going on with the LT Spice here kind of lets you see some of where that goes on too. I'll have to find some documentation for 555 as a synthesizer oscillator core.
Well, there was a time when there were a lot of timer ICs, like XR had a big selection of them. And really the 555, for whatever reason, just kind of won. And, my dream in life, which will never occur now, is to design something that is used that much by that many people for that many years. What an awesome,
Geez.
what a feeling that must be to be able to look back and say, wow, this has been going on for, 50 years now, or I don't know, however long it's been, and how it's in everything and everybody knows about it. So pretty amazing.
That's the equivalent of saying, I want to write the great American novel, though. Like that's. Hi, my next hack, Hacked Oscilloscope Plays Breakout, Hints at More, is a sweet reverse engineering of a dirt cheap oscilloscope toy by David Given from Poking Technology. And I say toy because this is a little $20 oscilloscope unit that's basically got a microcontroller and its ADC as the front end. So you don't have very much bandwidth on this thing. I think he says 200 kilohertz. But what you do get is a screen, a nice case, a few buttons, and this aforementioned microcontroller, which in this case is the CH32F103, which is a clone of the STM32F103, which is long in the tooth now. That's the chip that's on the blue pill boards, if that means anything to you. And he does do what he says he's going to do. He's got a sweet game in color of Breakout running on this thing. But, that's a little bit of a meme and kind of a joke. But it just shows that, you've got a known microcontroller in a nice box. Programming the thing is just a matter of getting the right debug pins onto it. And he actually solders it on, even though he says you could use the USB bootloader and, press the right button and use a DFU flash or something. But it's a lot easier and faster to just hook up the dedicated programmer to it. Anyway, it's really cool bit of reversing to get all of the pinouts mapped on this chip. Even if you know what the microcontroller is, you still have to reverse engineer the entire circuit to figure out where all of the GPIOs go, which go to the screen, which go to the buttons, et cetera, et cetera. And the way he does that's particularly neat if you have access to the brains of the system. He writes code to just wiggle this GPIO pin up and down, for instance, and then he goes probing around the board to find out where it ends up. And he repeats this until he's kind of mapped out all of the signals coming out of the microcontroller. That's a really great way to go if you already are flashing the microcontroller to begin with. And in the end, what's his conclusion? Well, it does make a sweet little video game terminal thing, at least if you can, if you've got your video games written for the F103 anyway, it's buttons and a screen. He thinks you could make, a controller for a home automation system out of it, and kind of speculates on all the things you could do. Ends up with, you could actually make an oscilloscope out of the thing, which is kind of tongue in cheek. But I've seen oscilloscope code for the blue pill boards that really pushes the ADCs on that thing and gets something like 1 megahertz, so factor of 5 faster than what this thing is spec'd with as it's being sold right now. So I wonder if he could just flash some of that other STM32 firmware on the thing and make it run twice as fast.
Maybe. I haven't looked at the inside of this, but it could be some of the input circuitry is really the limiting factor and not the CPU, at which point you'd have more surgery to do. But
I bet you're right.
But it could be. It could be they just underspec'd it to not have many quality problems, and so who knows? Maybe he could do that, just like you can overclock a CPU, right? The two things that struck me about this one, Elliot, I mean, one is nowadays we go, 200 kilohertz single channel scope, that's stupid. But I remember a time when we would have all killed to have that, and it's getting any kind of scope was just your dream bench acquisition, and it was super expensive, and you were buying old giant boat anchors that weighed, 400 pounds and needed constant repairs because that's all you could afford. So it's really interesting that, it's kind of like calculators. When calculators first came out, they were super expensive, and now you get them with Coca-Cola branded on them and you throw them away when the batteries are dead because they're free. Who would have guessed that would happen? But the other thing that strikes me is every once in a while you see somebody attempt to do this, but I don't know why none of it's caught on. Kind of like we were talking about the 555s caught on and other things didn't. You would think this form factor is kind of what everybody needs, right? You would think somebody would have a business, and maybe they do, and I just don't know about it, where you said, hey, here's a little box. It's got a screen. It's got 5 or 6 buttons. We'll silk screen the buttons for you. We'll put the back tray with the colors that you want and your logo. And it's got a battery and a USB port that charges, and you do whatever you want with it, right? I've seen a little bit of repurposed phones being used like that, but that's not really commercially viable. And I have seen a few attempts to do that. But it really seems like that's a business opportunity waiting for somebody, is to just have this kind of generic platform everybody needs. But instead, we've got 5,000 of those, right? Everybody's got their own little oscilloscope and their own little case and their own little home automation controller. And it's got, so okay, maybe it's got an extra button and a knob. Well, okay, but how much would it really hurt me to work with something I could get off the shelf? There's your business idea. And you can send me 20% of the stock for it when you make $1 million. So
I think that idea is really great. I don't know what the market for it is. I mean, I think largely it's a bunch of nerds like us, unless people make a smart, marketplace or way of sharing and popularizing the different firmwares onto it. And so it's just, a simple matter of, hey, I want this device to do this, download this firmware, flash it. That could actually make your dream work, like this kind of modular electronics busy box that then you can make it do whatever you want. That's kind of a cute idea. And that is kind of what he's suggesting using this thing as, although there's tons of utility in even a low bandwidth oscilloscope, especially if it's portable. Like, you have to imagine this thing is, it's slightly bigger than the pack of cards, right? Like, this is something and it runs on a battery. So this is something you can put in your pocket. It's something where, it's smaller than my multimeter. Right? Like, so anywhere I'm going and poking at signals with my multimeter, I could be poking at them with this oscilloscope, and I get to see the shapes of the traces too, not just this thing is on average 3.1 volts. So I think there is some utility here, but I do think it's also extra cool that it's completely and easily programmable, and now, thanks to David, fairly well reverse engineered so that it's trivial to put your own firmware on it.
So just to put it in reference, in 1983, you could spend a lot of money on a little solid state oscilloscope. We covered this a while back. And I don't know that I've ever actually seen one of these or even met anybody that says they've seen one, but it claimed to have a 5 megahertz bandwidth, which was actually more than I remembered. But on the other hand, because the screen were little LEDs, what was the resolution of that? It was like, what was it, 210 LEDs in some array. So
Yeah.
it wasn't going to be, it wasn't a precision instrument. And that's kind of a cool article too, because you can see some of the other things you could buy, and they were all insanely expensive as if they were even remotely decent. So this being 200 kilohertz in one channel, yeah, that's not great for $20. It's crazy. And like I say, from people in this era would have thought those were black magic. So, well, my next pick is a little bit of an interesting one from Metal Massacre Fab Shop, and it's Plasma Cutter on the Cheap Reviewed. The Asian markets, you get all these emails from them, and it's like, oh, look, you can get a $20 oscilloscope, and it's, is it any good, right? In this particular case, there's been a really big slew of welders and plasma cutters and things coming out. I assume because IGBTs are getting cheap enough that you can make them fairly cheap now. And the welders are insanely cheap. They're like $40 or $50. But the plasma cutter, I think, is running around $300. And I don't know about you, that's enough that I'm not really interested in gambling as much. And so it was kind of fun to see one of these cheap plasma cutters in somebody's hands. This guy's channel is really interesting. He's got old trucks and works on them. So it's not our usual kind of YouTube channel. He's clearly got that mentality of where he's just working on stuff and, making do with what he has. So sometimes we see channels like on 3D printing, and some of these guys are clearly, professional engineers, and they work with $1 million printers, and they know all the ins and outs. And sometimes you get those reviews. They're very useful, but sometimes they're a little picky, right? Because you're not going to get the $1 million printer. And I think it's the same thing here. The guy that was doing the review, I think his name's Matt. He's obviously one of us, and he's like, yeah, I've used a plasma cutter a couple of times, and, he had to experiment a little bit to get it working. That's useful too, because that's actually more realistic to what I'm going to do. I'm not the guy with the $1 million plasma cutter at work, and I just want to get a cheap one. So I thought it was really interesting. The upshot was, at least just for doing simple stuff, it seemed pretty capable. And I have a feeling with a little practice and a little reading, it might have been even better. So for $300, if you needed a plasma cutter, again, I'm afraid I'm going to burn my house down or my shop down. So I'm probably not going to get one unless I had some burning need for it. But it's kind of interesting that the price of that stuff is coming down and it's serviceable equipment.
Yeah, and if you read the comments, people are chiming in that they have similar units, and most of them, at least from the people who actually say that they own one, are positive. There's a lot of naysaying and, you should pay more and get better equipment stuff, but everyone who has one of these is like, actually, one guy even bought a $100 version of this from the supermarket chain Lidl for $100. Well, 99 euros. And this is Tom says that it works very well and, low duty cycle as advertised, but he's not cutting steel 6 hours a day. He's cutting steel once and then puts it away. And I think that's basically the takeaway here. If you want something that can run all the time and do serious work, this is not the thing you want. But if you just want something that can get a short job done, maybe with practice and maybe, with some cleanup afterwards, but, it can get the job done and then you put it back away. So this sort of thing makes some sense.
Well, we get into this debate a lot with like Harbor Freight, just to pick on them.
Yeah.
You get the same thing. People will say, well, that pair of ring pliers, it's going to break after you use it 143 times. I'm like, okay, but that's 10 years of me using it. So I'll throw it away and buy another one. And it still comes out less than buying the name brand. Soldering equipment's a good example of that too. I've got the very expensive Edson workstation. I love it. It's great. There's no doubt that it is way better than everything else I have. And if I hadn't bought it refurbished, it's 10 times the cost of everything else I have.
Exactly.
So Does that mean I should go buy that and just suffer? Well, no, I have other soldering irons because I can't afford 5 of them or whatever I need. So I think it's the same thing there. And, if you're, like I say, if you are interested in working on old trucks and stuff, I think that would be a really cool tool to have. I can't come up with a good reason why I need one, but I kind of want one. I just haven't been able to figure out why I need one. So
First, figure out the use case that justifies the purchase of the tool, then purchase the tool.
that's kind of the way I've been trying to live lately. So yes.
My next hack comes from Michael Vutrich, and this one is still up and coming, non-planar FDM 3D printing with 3 or 6 axes. And the 3-axis one is the one that really struck me here, and that is Michael's demonstration of printing a non-planar print. That is a print where the nozzle moves up and down as it's printing. So instead of being sliced into straight layers, it's sliced into curvy layers. So if you have a curvy object, the nozzle can follow the right shape, which makes it a lot stronger. All sorts of advantages. We'll get into that later, I think. But here, instead of adhering it straight to the bed, what he's doing is he's printing a first stage shape out of PETG and then printing over the top of this shape, kind of using it as a purpose-formed support material with PLA. And if the PLA and the PETG don't stick to each other, he can then just pull the second one off. And that lets him make a particularly complicated and lovely looking kind of wavy, I don't know what, sine wave rosette coaster shape or something, but it's definitely non-planar. That is not flat on both sides and really fantastic. 2 things about this I thought were really cool. One is his use of the non-flat printing surface underneath the print he's actually trying to print, and that's really cool by itself. I was going through his Twitter feed and he's actually done another trick where he makes a shape that would have impossible overhangs. It's a bit of a stunt. It's 3 benchies kind of at 60 degrees to each other printed up on a post so that they're all completely, each one of them would be a complete overhang. But he does this by first printing the little post and then putting it in a jig and then printing straight onto that. So each one of the benchies is printed straight up. He rotates the jig, prints the next one, he rotates the jig, and then prints the next one. And that's really cool too. And he's extended that here by adding the non-planar aspect to it. So he's got a wavy bottom surface and then he prints a second material on top of that to make a wavy top as well. This is a really cool stuff, but of course it does not come without a cost. And the cost is that there's no slicer software out there that will do this for you. So he's limited to kind of whatever mathematical shapes he can compute and write the path planning for himself. And he said in this case, I think he did it in MATLAB or something. If you don't want to go the full MATLAB mode, I guess there's libraries like Full Control G-Code, which we've written up before, which is kind of a Python library that lets you go from mathematically described shapes to easier G-code toolpaths. And that's another way to approach it. I do have to say, I think with non-planar 3D printing, we're still in the very early infancies, even though it's got a lot of neat practical uses, from extra strength along the different wavy dimensions to the kind of extra smoothness you get. And so we've seen things like airplane wings being printed this way so that they don't have layer lines along the airfoil, which would otherwise mess them up. But I just think it looks really pretty. And I'm always kind of disappointed that 3D printing, as we usually do it, is really kind of 2.5D printing. And I want to see more people taking advantage of the non-planar third dimension.
This one was super interesting to me. I love tinkering around with the 3D printers. And, it kind of reminded me of a couple of things. It reminded me of the technique I've done a few times where you print something and then you change filament. Like I'll print like a coin, and it's got holes where you want the writing or whatever you want on the coin. Then you load the different color filament and you set your Z-hop really high. So basically every time the head moves to, it goes up 5 millimeters or whatever, clears everything on the coin, goes in and literally draws down on the surface of the
Oh, that's
coin.
smart.
that works really well. I believe, I'll look and see. I think we've done a post on that. I'm sure we have. And it really comes out nicely. And it's fun to watch, but it's kind of that same idea. Like you say, it makes it a little more 3D when it goes, I'm going to go over this part and then come back down, as opposed to just swipe, 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 swipe. But the other thing, I've been really interested in playing with this, and I just haven't, you know how it is. We write about all this stuff, and then you rarely have time to actually go back and play with it. But there's been a couple of bed sensors we've covered. I put a link in the show notes. One of them was called BD Sensor, and it's over on Hackaday.io. And I don't know this, but I think it's a time of flight sensor. So it's got super great resolution, and it's real time. So he's actually showed on a video where you could like lift the bed up, and it doesn't care. It just tracks the bed, right? And it says, oh, okay, here we go. So now I don't know if it requires like a metal surface or not, but if you had the right kind of sensor, that would be one way to do this without slicing, right? Is you make some form, just like you were talking about, his surface is not level either. So if you had a form that the sensor could detect and then you print the layer, well, it's going to conform to that form. And so that seems like that would be another way to get there. You know, it wouldn't be ideal for a couple of reasons, but it might be easier than rewriting slicer software to understand the nonplanarity. And you could even 3D print the base, right? You print the top would be the contour you want. That's easy to print. And then when you then do the real print, it, you know, goes over that contour. So those were the things that reminded me of. I think, like you say, this is one of those things we're going to have an explosion of eventually, but right now it's still early days. And maybe some of the 3D printer companies that are trying to differentiate themselves from the leaders, this would be a good place to innovate, right?
I like your idea of mapping out the surface. Right now, we just always assume that it's flat, or maybe flat and a little bit dished in a bad way, and try to compensate that. But what if, like you said, you took a time of flight sensor and could actually kind of image whatever it is that's already on the print bed? That would let you do kind of multi-part prints in a way that you can't now. And that would actually be really interesting. One of the things that Michael runs into here that I hadn't even thought of is that he has to modify his printer a little bit because it has a Z height gauge, a normal Z height gauge. And if this thing is going to bonk into the print as it's going along. And so if you want to do non-planar printing, you do have to think about the whole print head needs to be clear as it's going up and down, and not just the part that the plastic's coming out of, but any like Z probes or whatever else you've got strapped on there, the fans. I guess your nozzle, if you're trying to do really tight up and down movements, your nozzle actually has to be kind of particularly sharp as well. If your nozzle has like a 45-degree slope on the side, that kind of limits, how slopey your non-planar surface that you're printing can be. Hadn't thought about that until looking at Michael's work here.
Well, my last hack of the week is from Nathan Butts, and it was actually a presentation for the Society of Amateur Radio Astronomers. But you know me, I love the citizen science. That's something that really appeals to me. And Nathan does this presentation that essentially says, hey, with SDRs, there's no better time than now to do radio astronomy. There's still things that are something that amateurs can do with, sub-$1 million equipment. And it's just a nice presentation. I mean, it's nothing, it's not anything that's going to rock your world. But I think if you've ever thought about doing that, he makes the point that like now so many people live where it's really not feasible to put a telescope in your backyard of any size and look through it because you've got so much lights and, the street lights and all the light pollution and everything else. Radio telescope, you can use it during the day, you can use it in the lights, you can use it anywhere. Now, I guess if you live next door to a TV station, maybe that's a problem. But even then, you probably have better luck filtering that out than filtering out street lights. I think there's a lot of opportunity there to do things. And the other reason I wanted to highlight it is that was one talk of many given at their conference. And if you basically go up to that channel, there's a bunch of interesting things depending on your appetite for topics. Some of them were fairly complicated topics. And so it's well worth checking out. I guess they scheduled it in Dallas during the eclipse, and I'm sure that was no coincidence. I guess they all ran outside to watch the eclipse when it happened. Yeah, Nathan did a great job of kind of talking about, what you needed to get started, why you might want to do it, and how to kind of get started on a shoestring. So, Dan's got the $50 ham. Maybe we should have the $50 radio astronomer series.
Yeah, right. That's a great idea. What I thought was really cool about this, you mentioned how it's relatively easy to do astronomy because it depends a little less on your circumstances. It's true, but at the end of this talk, he does get into, if you can't put up a really big dish in your backyard or whatever, there's some things you can do and some things you can't. And I thought that was very realistic to say, look, if you have this much space in your backyard, or if you have to do it portably, or if you X, Y, and Z, whatever your limitations are, here's the kind of science you could do with that. And I thought that was a really neat approach rather than, taking, I don't know, NASA's approach, which is here's the science we want to do. How can we engineer the device to do it? He's saying if you're just a hobbyist, take your constraints as binding and then figure out what's the coolest science you could do within them. I thought that was pretty cool.
Well, it was interesting too that apparently people make their data sets available. And so even if you don't want to set up anything and you just have an interest in crunching data, which I know some people do, there's contributions you can make without even doing any actual radio observations yourself. So
not gonna lie, that's what a lot of astronomy is these days, right? Like not everybody is sitting there at the telescope. A lot of people are, the telescope runs remotely. They're back at home working on analyzing the data. So yeah, not only is it the cheap and easy way to do it, but it's not actually that far from modern scientific practice.
it reminded me of a site we've talked about a long time ago now, I think, back in 2016, which is Zooniverse. And, that's one of those where NASA or somebody can say, wow, we have all this data. If people would volunteer, we'll train you what we want to look for and you go wade through this data for us. So at the time, they run different projects at different times. They were running Radio Meteor Zoo. And I think also they were the ones that found the prehistoric burial mounds from all the satellite imagery and stuff like that. So if you've got a citizen science bent and you don't want to build any hardware, that's another way to go is Zooniverse. I don't know what their current projects are, but you can check out their site and there's plenty of it.
For my quick hacks, I wanted to start off with Shahram Mokhtari's A Rogue Ally battery mod you ought to try. The Asus Rogue Ally is a portable gaming computer. It's a lot like a Steam Deck, but kind of a Windows-only version. It's a little bit more powerful, but that means it slurps the batteries down too. Here, Shahram has a completely 3D printed back case for the thing that also lets it slot in a laptop battery so you can play video games for twice as long. It's a really sweet idea as well as being a very nice implementation. Science Buddy's custom dog door prevents culinary atrocities. He has a dog who likes eating his cat's poo and is trying to make an automatic door to close to keep the dog from going in. He's using a magnet around the dog's collar and a bunch of reed switches to sense it. And it kind of sort of works, but reed switches aren't all that sensitive on a good day, and magnetic fields fall off as the radius cubed. He's got everything going wrong with him. This looks like it should be an RFID application. So, Science Buddies, if you're out there, look into RFID. Source code to the 1999 FPS game Descent 3 released. This is being released by someone who worked on Descent 3, Kevin Bentley. It's really cool. Descent's a really fun game. It ends up being kind of a 3D first-person shooter game. And this makes me think, now that this has been open sourced, will the next Can It Run Doom be Can It Play Descent? And bringing up the rear, Wendy, fail of the week. Can an ultrasonic cleaner remove bubbles from resin? A lot of times people use a vacuum or pressure, respectively, to get epoxy resin to degas. Wendy was thinking, can I just shake it around? And the answer is a resounding no. Ultrasonic seems to keep the bubbles moving around inside the epoxy rather than push them to the surface. And she thinks actually maybe even creates some bubbles inside of it due to cavitation, or at least shakes the bubbles into smaller bubbles. Does not get rid of them at all. In fact, maybe even makes it worse. I love that she tried, and let us know that it failed.
Well, my quick picks this week, if you want to learn something, a lot of times playing a game about it is not the worst way to go. And Oh My Git has a game that you can play to learn how to use Git. And certainly, even if you use Git a lot, there's a lot to learn about it. It's a big system, so it's a fun way to increase your knowledge of Git, especially if you don't know anything about it. Dominic Pajak has a very interesting simulation of the BBC Micro, and it's, you say, oh, another vintage computer emulator, but this one's actually made to be played with a headset. And so you put your headset on and you're sitting in front of the computer and you can type with your fingers. If you don't have a headset, you can do it in your web browser. I did notice like the minus and equal keys and plus keys did not work on my keyboard. That could be my problem, but it did stop me from writing any significant code for it, but it did work. And last but not least, 0033mer had a really quick tip that spawned a lot of interesting comments about recycling riser wire for breadboards. And so essentially he goes to junkyards, gets the riser cable out of demolished buildings, which have 100 pairs of nice solid wire. He cuts it open into 10-foot sections, puts it all in a pencil box, has a little German-made wire stripper, and makes little custom breadboard wires out of it. And of course, as you would imagine, 15 feet of this that you can probably get for free or next to nothing is pretty much a lifetime supply of it. So it was an interesting bunch of comments on that one too, about how people harvest wire from other sources like that.
I'll admit to having a little bit of phone cable that I've used for breadboarding.
He needed thermal strippers though.
You and your thermal strippers.
I'm spoiled. I have expensive tools.
I do it by feel.
Use your teeth. That's the real.
Ask my 0 out of 10 dentists recommend. Well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. And I wanted to pick Tom Nardi's Chandra X-ray Observatory threatened by budget cuts, because the latest budget request coming out of NASA has them slashing the Space Observatory's budget nearly in half in 2026 and leaving it at that level until 2029, when it's going to drop even further. And so the question is, what's going on with the Chandra X-ray Observatory? Tom does actually a really great job here of talking about not just why you want an X-ray space telescope in addition to all the other space telescopes we've got out there, but also in pointing out what's really going kind of wrong with Chandra, and that is that its temperature controls are not working quite right. And this makes all the scientific observations coming out of it noisier and hard to deal with, especially since what's happening is that the temperature seems to be varying erratically. And so this throws in kind of non-deterministic noise into the data and makes it hard for people to do their science. And so I think that's part of the story here, is just that the sensors on board are proving to be less and less useful over time, and it does seem to be getting worse. That still doesn't mean that you can't get good work done, and there is a open letter written by Dr. Patrick Slane, a letter to the Chandra community, kind of talking about these claims, and he does point out that even though it does seem to be getting worse with respect to these temperature fluctuations, it's actually still in spec, and it's not something you wouldn't expect anyway for an orbiting telescope that's now getting on toward 25 years old. Now, just for a little background, Chandra was one of 4 space telescopes out there. I'm sure you have all heard of Hubble and the James Webb, but those are kind of crowd pleasers because they observe the universe in optical wavelengths. And so, we see out of them what we want to see out of them. But Hubble was just one of 4 telescopes in NASA's 1980s, 1990s Great Observatories program, where they decided to put up a slew of space telescopes working at different wavelengths. And so you have Hubble working in visual, you have the Compton Gamma Ray Observatory in gamma rays, Chandra X-ray Observatory in X-rays, And the Spitzer Space Telescope, which was an infrared telescope and is kind of completely eclipsed now by James Webb, I have to say. And this was a kind of a grand idea, and it was actually Lyman Spitzer's idea to put up a broad range of space telescopes, kind of blanketing all of these wavelengths, and in particular with gamma rays, X rays, and infrared. There are wavelengths that penetrate the Earth's atmosphere really poorly, and so you really need space telescopes to get sensitive readings on this sort of stuff. Much less so actually with visible light, and that's A, that's why we see in those wavelengths, and B, I guess you have to worry about the atmosphere, and it is true that Hubble and the optical parts on James Webb get fantastic images and, better than you could through the atmosphere. But really, it's these other three that are kind of the real science stars of the great observatories. And the Compton Gamma Ray, I think, is down now, and I don't know what happened to Spitzer Space. I think it's down too. I think both of these have returned to Earth already. Hubble's still up and kicking, but it also is kind of eclipsed by the optical parts on the James Webb. The only one that's still doing absolute best in class science out there is the Chandra X-ray Observatory. And that is kind of what seems a little bit sad about this in a way. On the other hand, there's a proposal, and I think it's just a proposal. I'll throw in the Wikipedia link for you. The Lynx X-ray Observatory is a proposed successor could be the successor to the Chandra. And if that's the case, then some of this budgetary shrinkage for a telescope that's having more and more technical problems as it gets older and older makes a lot of sense. And I think if the plans for the next generation X-ray telescope are serious, then that makes that makes the pill of defunding Chandra a lot easier to swallow.
Well, it always amazes me. There's been studies done that if you ask American citizens how much is NASA's budget as a percentage of the federal budget, you get numbers that average around 20%. And the real number for 2020, which is the last year I have any data, is 0.48%.
Thank you.
I've read estimates that the average American's taxes, $9 of it goes to NASA. And, even when we were in the middle of the space race, I think the peak was still under 5%. So it's not even like, oh, well, it was 20% at one time. No, it's never been 20%. It's never even been a minuscule part of 20%. So, sometimes you wonder why there's so much angst over what to the feds amounts to a very small amount of money, but it's the perception of it. And I don't know. I mean, if it were a sporting event, which is kind of what the space race was, right? It was the Olympics of space. It was us against the Russians. We had to get the gold medal. Then everybody's willing to write the check for that. But now that it's just we're doing boring science, it's a lot harder. And we kind of live in an echo chamber because I don't know about you, the people I hang out with, they are all space nuts, and they want NASA to have money, and they want the Chandra, and they want all these other things. But if you just go walk around in the normal world with ordinary people, they don't understand why we're spending money on that when we could build another ball stadium that charges us $9 for hot dogs or whatever. So that kind of frustrates me, is in the scheme of things, there's no reason we couldn't fund all of this stuff and not even blink. But it turns into this big affair. NASA's very visible. And, the idea that they've ever gotten 20% of the budget is just laughable. So, yeah, 0.48%.
And in case you're wondering exactly what kind of science Chandra is doing up there, X-rays are really good for seeing things that are super energetic. So it's good for supernovas, galaxy clusters, and it's also good for the things that you can't see in visible light. Black holes give off X-rays. And so there are a number of things you can look at out there, questions, open astronomical questions to be answered that you can really kind of only do in the X-ray spectrum. And so a hole there is a problem. Tom also points out that other space satellites have X-ray sensors on them. None of them are at all as good as Chandra's, but it's not like we're going to go blind in the X-ray when it comes down. Cross your fingers. If the Lynx program is due to set up, then we might get a newer and better space telescope in the X-ray in the quote near future, but this is the near future in the large space planning future, which I think is probably 10 years at the earliest.
My pick this week is Arya Varnova's Logic Analyzers Decoding and Monitoring. And so, Elliot, you and I have talked about logic analyzers before. I still have a Gould Biomation giant, 1975 500-pound logic analyzer. Well, maybe not 500 pounds, but that's a really great tool, and I think it's one we don't use enough. And what's really nice these days is they're fairly cheap. She's got some of these FX2 boards, those are literally commodity price. And open source being what it is, we've got great software for it in the form of SIGROC. So she talks about, writing a Python parser for data that interfaces in with SIGROC. And that's one of those things where even if you had the $20,000 logic analyzer back in the 70s or 80s, you were beholden to the vendor for whatever they wanted to give you, and what they wouldn't give you, you probably just didn't have. So now that's not the case. If you've got some wacky, funny protocol you want to work with, you can go grab SIGROC, download it all, modify it to your heart's content, and make it work for you. I think that's really awesome. In this particular example, she's looking at the I2C bus of the pencil soldering iron and parsing the data off of that. So one of those things that is easier to do than I think people realize. SIGROC has got support for the Pi Pico. So you can even just grab a Pi Pico and then all of a sudden have all this data analysis, decoders, parsing, all this at your fingertips, the nice graphical output. Or you can, buy some of these cheap boards. It'll also work with a surprising number of oscilloscopes, meters, all sorts of other types of units that you can get. And I guess that's the other thing that's very interesting to me is the price of oscilloscopes that are mixed signal have come down. And I'm hoping to see more support for those in SIGROC, although I'm sure that's coming. But, it used to be having a scope that had a couple of channels and some digital inputs to work like a logic analyzer was a really high-end instrument. And now, I've got a scope now that's 4 channels with 32 bits of logic analyzer. And it was fairly cheap. Now, the problem was they wanted to charge, $500 for the probes. And then it turns out somebody's got on eBay's got a $50 version of the probes, and it works great. So that's another case of where we're getting capability that would have been insanely expensive not long ago. And now it's something that's reasonably within reach and probably in 10 years will be super common.
I love this article because I learned a couple things from it. And one is that they're selling those little Saley logic analyzer ripoffs without even the plastic case on them anymore because they weren't cheap enough with the plastic case on them at like $6 or whatever. Now you can buy them without the case and save a couple extra dollars. It's really fantastic. The other thing is that I really do love the way she does the scripting here. And so if you're wondering what that's all about, this is starting off with sniffing an I2C line, and that has, there's the start condition when the clock line goes up, and then there's read to this address, write from that address kind of commands going across. And that's okay, but it's a lot of stuff to parse. And if you knew what was going on in those addresses, you would know kind of what the command means rather than just what it's doing. And so that's what she's doing, is writing some very simple Python code actually to kind of translate these otherwise inscrutable results into kind of, oh, here it's, writing to the status register. Oh, here it's writing to the measure register, et cetera, et cetera. And I think that's really useful and cool. And the last bit is that there's this crazy situation where there's a UART line with multiple baud rates going on. And so it's, there's a bootloader at one speed and then a flashing at another and then the software running at a third. And I think that's really cool that if you did this with a little USB dongle, you'd have real trouble. You'd have to be changing the baud rate all the time. But it's actually easy enough to write a little script that with the SIGROC command line that figures out what baud rate is currently being used at any given time and decode it that way. So there's just a whole bunch of kind of tricks that you can easily do once you're able to code all this stuff yourself. And I think that's kind of the take home here. Al, you were talking about like the multi-million-dollar signal analyzers of old, and like my scope is a mixed signal scope from 20 years ago now, and it has all of these great decoding features that you can buy at $500 a pop from Agilent, right? And that is where it really hurts. And even so, they don't have all of the features you could code up yourself in Python for free, and it's not even all that much work to do it. So I think that's the real power here, is that not only do you have cheaper logic analyzer than you used to in the past, but you've also got more and better and easier to read and easier to use, more helpful in your reverse engineering logic analyzer than you used to in the past. And it's all just by writing a little bit of a plug-in code yourself for it.
I'll give an unsolicited plug. You were talking about the little FX2 boards being cheap and not having the cases. So some people are differentiating because the CPUs are now so much more powerful. I've got a couple of these now. They're made by a company called Sipeed, S-I-P-E-E-D. I think that's how you pronounce it. It's an S-Logic Combo 8. So it's actually one of these little logic analyzers. Looks just like a normal one, except it's got a label on it that's got 4 colors and some description, and it's got a button and an LED. And so if you push that button, the LED changes color, and the label on it tells you what the function is. And so it'll be a logic analyzer if it's blue. If it's red, it's 4 TTL level UARTs. If it's green, it's an ARM debugger. And if it's yellow, it's a RISC-V debugger.
Oh, how fun. Yeah, right?
And I mean, like you say, instead of $6, I think it's $8 or something ridiculous. It's not, and it comes in a big plastic case and a little plastic case. And inside the black plastic case, there's, little grabbers and wires and a USB cable. And so it's a little premium compared to it's a bare board that does this one thing. But I liked it so well, I bought another one. So I've actually got 2 of them sitting on my bench, and they're super handy.
And if that's not premium enough for you, Tom had a look at the new Bus Pirate 5, which kind of does all this and more on the device. And it's got a fancy schmancy OLED screen and color, and it looks like it's making really good use of it too. What are they trying to get for these? Maybe $40? It's a bit more money than $8, but at the end of the day, it does a lot more, and it kind of has this whole interactive console aspect to it. So I think that's pretty rad too. Also does voltage source and a few other things too. No better time to be scripting your desktop logic analyzers than the present. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to click the links, they are over at hackaday.com/podcast. And if you want to send us hot tips at hackaday.com. And until next week,
keep those hacks coming.
Who cares, right?
This has become too complicated, Elliot.
Did I type that right? Is it Woot? What font is this? Is that an L? Oh, I got it. And this could be your title. It's so bad. A spicy 555. Come on, because it's an LT spice.
Oh, spicy.
Come on.
Oh,
see? Yeah, he's bad enough. It made you groan. That's the seal of approval, I think.
There you go.
I'm taking it.